Hello everyone, my name is Aman Sharma. I am a PhD scholar in the Central University of Himachal Pradesh under the Department of Physics and Astronomical Science. Today I am going to present about the particle accelerator, which is a cyclotron. I will discuss about its construction and working, its principle and the definition, and at the end we will see its applications and limitations. In the second part of this video, we will see the mathematics behind the working of cyclotron. So let's move further with the first part, which is the construction and working. So let's move toward the slides. Here, construction and working of a cyclotron. Basically, it is a cyclotron. This is how a cyclotron looks like. Here is the outline of today's topic. We will discuss definition, principle, construction and working, applications, and limitations. So, what is a cyclotron? What do you think about a cyclotron? Basically, it is a particle accelerator which is used to accelerate the some particles. But what kind of particles are those which are to be accelerated? It should be positively charged particles. Look, no neutrons, no electrons, only positively charged particles. So it is a device used to accelerate the positively charged particles like protons, neutrons, alpha particle, which all are positively charged, to carry out the nuclear disintegration. So here is the first cyclotron which was discovered in 1931. So what is the principle behind the working of a cyclotron? So it is based on the fact that when a positively charged particle is made to move time and again in an electric field by using a strong magnetic field, it gets accelerated and acquire a sufficient amount of energy. This energy is used to hit the target, which is our aim. So this is what takes place inside a cyclotron. These are two Ds. We will discuss all this in the construction part of the cyclotron. So let's move further toward the construction. Uh, it holds two hollow D-shaped metallic plates, which I will show you in later. Here, these are the two D-shaped metallic plates. These are connected to a high frequency oscillator. We are seeing this. These are connected to a high frequency oscillator which will provide the electric field to these Ds. Here it is D1, it is D2 uh, connected to an high frequency oscillator which provide the electric field and a perpendicular magnetic field. We will discuss all about this. The charged particle inside the Ds is shielded from the electric field. See, here is our charged particle, which is positively charged particle. We can say that positively charged particle will get attracted toward the negatively charged plate. But when it is inside the D, due to electrostatic shielding, the force inside the D becomes zero. So in that time, the magnetic field will provide the magnetic Lorentz force to move it in the circular path, as I discussed. And then let's come to the working part. Initially, when an electric field is applied, D1 is negative and D2 is positive. We can assume that the polarity of D is at the starting that D1 is negative and D2 is positive. So we can say the positively charged particle will get attracted toward D1, which is negatively charged. See, this is how it works. The positively charged particle will go toward the D, and then it get electrostatic shielding inside the D, and after that when magnetic Lorentz force give it the circular region, it will get it. In the same time, what happen, the polarity of D's get reversed, like when D1 is negative, D2 is positive. But when the electron describes the when the positively charged particle describes the semicircle, the polarity of D's get reversed in the same time. So a positively charged particle will be attracted towards D1, as I discussed, Inside the Ds, the force due to electric field becomes zero, electrostatic shielding, and the perpendicular magnetic field provides a circular path to the charged particle. As the charged particle describes semicircle, the polarity of the Ds get reversed. We have discussed all these things. Now charged particle will be move toward D2. हो गया ना? जब when the positively charged particle describe the semicircle, D2 is now negatively charged, so it will get attracted toward D2, and again in D2 what will happen? Electrostatic shielding will happen, and then after that magnetic field which is applied perpendicular to these Ds, and it will give the circular orbit. And when this semicircle, when positively charged particle describes the semicircle, in the same time polarity get reversed, D2 become negative and D1 become positive. So now it will move toward the negatively charged D. So this process repeats time and again until this process repeats time and again till charged particle acquire a sufficient amount of kinetic energy and are taken out of window to hit the target. This is what happened inside a cyclotron. Look, here is the positively charged particle start moving in the circular orbits, and these are some applications. What are the where it is used actually? To synthesize the fresh substance in the field of material science, to improve the quality of solids by adding the ions, and to study the nuclear reaction, and to produce the radioactive material for medical purpose. And there are some limitations as well, like neutrons cannot be accelerated. Like we see, all the D's are, both D's are attracting when it is negatively charged or when it is positively charged. Polarity get reversed. So a neutral particle cannot be attracted by it. So it is a huge mistake. And electron cannot be accelerated. Why? Electron can be get attracted toward positively charged D. But why electron is not accelerated using cyclotron? The reason behind it, the mass of electron is very small, and particles with negligible mass that cannot be accelerated using it, and the positively charged particle cannot be accelerated beyond limit, because with the as we know the relativistic relation that mass and velocity are related. So when particles start moving with the very high velocity, the mass increases. So after that, particles cannot be accelerated. So that's all from today. And in the later part of the video, I will discuss about the mathematics behind this. We will see the time taken by positively charged particle to complete one circle, and what is the maximum kinetic energy that a particle is going to acquire. We will discuss all those in next part. Thank you.